Hello, let's discuss best matrix question from today's Codechef contest. A matrix of size n into m is said to be best if and only if all the following conditions are satisfied. Mod a x1 y1 minus a x1 x2 y2 is equal to 1 for all adjacent pair of cells x1 y1 and x2 y2, and they are said to be adjacent if they share at least one edge. And similarly, ax of y is equal to ax minus 1 y plus ax plus 1 by 2, and similarly y coordinate. You want to make it best matrix, find the minimum number of values that need to be changed to get the best matrix. The both coordinates can go up to 100 and values can go up to 109. So let's start discussing it. So let's take one dimension first because it is slightly easy to understand. So let's take 1D array which is horizontal. So the question is saying that the value is average of its before value and the next value. So for example, from this, if it is a, b and c, a plus is equal to 2b. So from this, if we try to rearrange it, we can get c minus b equal to b minus a. And they also mentioned that the difference should be 1. So it can be 1 or minus 1. So the difference is b minus a and it is equal to 1 or minus 1. And similarly, this is equal to c minus b as well. So this is for horizontal one, and let's schedule this for vertical one. Similarly, this value is average of above and before one. So similarly, if we try to arrange the equation, we will get the same. The difference of every two adjacent is same, and that is equal to 1 or minus 1. So we got one dimension, and now let's try to discuss for two dimensions. So let's take 4 into 4 matrix, and now for the first row, let's assume that values are x, x plus 1, x plus 2, x plus 3 and x plus 4, because we discussed that the difference should be same for all adjacent ones, and that should also be equal to 1 or minus 1. So now let's assume that for the first one it is 1 for the first row, and similarly now assume that the difference is minus 1 for the second row. So let's assume that the last value is y, and this is y plus 1, y plus 2, y plus 3, and this is y plus 4. Because the difference is minus 1, so the values will decrease from left to right. And now the condition should satisfy for these both as well, right? Because these two are also adjacent. Because the first one is 0, 0, and the next one is 1, 0. So even these two are adjacent. So the condition should be satisfied for every two adjacent values. So x minus y minus 4 should be plus or minus 1. And similarly, difference between these two as well. So x minus 5 plus 4. So x plus 4 minus 5. This is x minus 5 plus 4. This is plus or equal to minus 1. So if we try to take 4 this side and minus 4 this side, we will get that x minus 5 is equal to 3 or 5 from this, and x minus 5 is equal to minus 3 or minus 5 from this. So surely there is no intersection of this, because this suggests that x minus 5 is greater than 0, and this suggests that it is less than 0. So there is no x and y which is satisfying this both. So from this, the main idea is, if the first row is satisfying the condition, difference is 1, the second row should not be minus 1. Sorry. So even the second one should be 1, because if this is minus 1 and this is 1, the given condition is not going to satisfy for any values of x and y. So all rows should have same difference, whether it can be 1 or minus 1. So similarly, same with the columns. So the main idea till now is all rows should have same difference, and that should be 1 or minus 1. And similarly, all columns should have same difference, and that can be 1 or minus 1. And now let's assume that the initial value, the 0, 0 is v of 0, 0. And now let's assume a point v of ij, which is I rows and j columns from the 0, 0. So let's take the difference in the x is the difference in horizontal axis is x. So this can be 1 or minus 1. And similarly, the difference between every two adjacent ones in y dimension is y, and this also can be 1 or minus 1 as well. So if the difference is x in the horizontal and y in the vertical, and in 0, 0 value is v of 0, 0, then what is the value of v of ij? It will be simply v of 0, 0 plus I into x plus j into y, because for the number of rows between this and this is I, and for each adjacent one the value is increasing by x, so the net increment is I and x, and similarly for the y it is j and y. So v of ij is equal to v of 0, 0 plus I of x into j of y. And now let's try to observe other thing. So the both values of x and y are limited to 1 and minus 1 only. So x can be 1 or minus 1, and similarly y can be 1 or minus 1. These two are independent. So For example, we are at index I and j, and now we are trying to find the value of v of 0 0, for which the present value need not be updated. We are at index I comma j, and we are trying to find the value of v of 0 0, for which the present value need not be updated. And what is that value? From this we can see that v of 0 0 is equal to v of ij minus I of x into j of y. So if we are at I of j and v of 0 0 is this value, then we no need to update the value of v of ij, because based on this the condition is always satisfied. So for every index for a fixed x and y, let's assume that both are 1 and 1, the difference is positive in both, and if this is both and 1 1 1, and we are at index ij, and now we are trying to find v of 0 0, for which the present value need not be updated. So this will be this, according to this, x is fixed and y is fixed and it is 1 and 1. I and j we can traverse from the loop to traverse all the values, and v of ij is given. So from this we can use a map and store for what values v of 0 0 is required, so that that value need not be updated. So we will fix x and y. There are total 4 cases because both can be plus 1 or minus 1. So 2 into 2. So there are 4 cases. And for all 4, let's traverse whole vector, whole 2D vector. And for every value, let's use a map to store what are the values of v of 0 0, such that those values need not be updated. So we can store these values in map. And finally, we can find what is the v of 0 0 maximum, such that maximum numbers need not be updated, so that minimum changes are required. So we can find that, and if we are able to find the maximum value, the answer is total cells minus maximum value, because for the maximum number of values there is no need to update. For rest of the cells we have to update. So the answer is total cells minus maximum. So it is n into m minus maximum. Let's check the code. So we are taking vector, two-dimensional vector, and we are inputting the values, and now initially answer is 0. The values of x are minus 1 and 1. So the loop is minus 1 to 1, x is equal to minus 1, x less than or equal to 1, and x plus is equal to 2, because you want only 1 and minus 1. So minus 1 and 1. Similarly for y, minus 1 and 1. And we are taking a map. We are traversing the whole grid. We are traversing the whole grid. And we are finding the value of v of 0, v of 0 0, such that the present value need not be updated. And this is equal to v of ij minus I into x minus j into y. So and now we are storing in the map. So after traversing the whole for present x and y, we are finding the maximum frequency of all. So similarly for all cases, we will get the maximum frequency that is there. So after that, the answer will be n into m minus answer, because this is the number of values that need to be updated to get the given condition satisfied. Hope you understand. Drop a like, comment below. See you in the next video.